Hi, this is Mrs. Davis. This is AP Pre-Calculus. We are on the Unit 1 review packet. We're going over the review questions, and we're on Section 6 right now, and this will be the video on sample free response number 1. All right, so if you look at our question here, they try to make it like you would see on the AP Classroom, so we got to answer it in all the ways that they would like to get answered so that we can get all the points that are necessary for this. So this would be worth 6 points. They are all worth 6 points. And so we could probably assume it goes 2, 2, and 2, but sometimes it might be different. So let's just dig in. First, we see that we have a function f, and it's given to us as an equation of the function, and then we have a second function g that is giving us some information about it. Okay, and so we have two functions. So A says express the end behavior of g using limits. Give a reason for your answers. Okay, so the end behavior, our answers are going to be talking about even degree, odd degree, leading coefficient, positive or negative. Those are going to be the reasons. So let's try to remember that. So we'll label it A. You always label what you're working on. And it has degree 4 and leading coefficient 2. So that means that this would always point, and make sure you see that we're talking about G, because they'll tell you which one they want to deal with. So our function would always point down because of the negative leading coefficient and even degree. So G has end behavior the limit as x goes to negative infinity of g of x would be negative infinity, and the limit as x goes to positive infinity, g of x, that would also be negative infinity. And that's, we're going to say, because g has degree 4, we can even add the even, right? It's even degree and a negative leading coefficient. Okay, so that would be the reason for A. Okay, so you would probably get, if we were going over this, you'd probably get a point for stating the end behavior, and the reason would be your other point. So that part of the free response would be worth 2 points. So we'll say A is worth 2 points. Oh, there's my cat. She needs to stop crying. Okay, let's go to B. Back to B. It says, find all x for which f of x is greater than 0. So now we're looking at the function f. So let's rewrite it down here so we have it next to us. F of x is 3x cubed minus 11x squared minus 4x. Okay, and so it wants to know, this is an inequality, it wants to know when that is greater than 0. And so we are going to have to do a simple graph, a sign chart, and say what's going on with it. So we have to factor it first, so we can factor out an x, and we get 3x, x squared minus 11x minus 4. And that's greater than 0, so I have x. And this would factor to, let's see, factor to 3x plus 1 and x minus 4. We can check that. Okay, FOIL it back. That would be 12x, negative 12x plus a 1x. So that would give you your negative 11x minus 4. So that's factored right. So now we can use our graph, okay, and or make one. And we have zeros at negative 1/3, 0, and 4. And we had a third degree positive, so, and no multiplicity. So it has to come through 4, through 0, and through negative 1/3. So now we have our end behavior to help us decide when it's greater than 0. So this would be negative down here, and then positive, and then negative, and then positive. We're following the graph. And so my answer would be, where it is greater than 0 would be an interval notation. So let's say f of x is greater than 0 on the intervals, because remember, it's a free response. We're going to write this out. Negative 1/3 to 0, and 4 to infinity. Okay. Looks like I got negative 1/3 to 2. Did I do something wrong with my zeros? Let's see. Hang on a minute. No, that's right. All right. So now I'm kind of out of room for C. I'll do C up here. So let's get rid of that. C has 2 parts, so CI. We have another function, R, that's making it the rational function of f of x over g of x. So it's saying, determine if the graph of R has any vertical asymptotes. Write equations whose asymptotes for those asymptotes, or state that no vertical asymptotes exist. Give a reason for your answer. So we have to write the g of x function. We have not done that yet. We've just used what we knew about it. So we're going to come up here, and I'll do it here to write g of x. Because how can we put f of x over g of x without this? So it has a leading coefficient of negative 2. I'm getting that from right here. And it has zeros of negative 3, 2, and 4, multiplicity 2. So that would mean I have x minus 2, and x plus 3, and x minus 4 quantity squared. All right, so that must be what g of x is. So if I have to write f of x over g of x, that would be f of x was given to me, and I can go to my factored form. Here was my factored form. Okay, so x times 3x plus 1 times x minus 4 over what I decided was what I got g of x for. So that would be negative 2, x minus 2, x plus 3, and x minus 4 quantity squared. And that's equal to r of x. So we've now put what r of x equals. All right. Okay. Do we have any common factors? We do. So we can cross out our 4's, and we would not have a whole, but we would have a 1 left over for a vertical asymptote at 4. And so I think that's what it's asking. Does R have any vertical asymptotes? And write equations or state that there are none. So we are going to say that we would have, let's simplify it now because it didn't ask about wholes yet. So this would be x, 3x plus 1, and then negative 2, x minus 2, and x plus 3, and x minus 4. So I've got 3 different asymptotes, so I have got to write that. So r of x has a vertical asymptote at x equals 2, x equals negative 3, and x equals 4. And now it says, give a reason for your answer. So we have to start with the limit. So we're going to say the limit as x goes to, we'll just do 2 from the left, of r of x is equal to, and so if we're looking at this one and we're putting a 1.9 in, you end up with positive, positive, negative. So it's like, let's see, positive, positive over -2, and then that would be negative, and then positive, negative. So that's a lot of them to say that that would be going to 1, 2, 3. So that would be negative infinity for 2. So let's erase this, and I can just say that would be negative infinity, and the limit as x goes to 2 from the right of r of x comes out to be positive infinity. So we've gotten 1. Then the vertical asymptote at -3 would say limit as x goes to -3 from the left of r of x. And if you put the numbers in for -3, you get a positive infinity coming from the left. And the limit as x goes to -3 from the right gives you a negative infinity. And lastly, the limit as x goes to 4 from the left of r of x is equal to infinity, and the limit as x goes to 4 from the right of r of x equals negative infinity. So you'd have to figure those out. I had figured them out earlier, so that's why I was so fast to say what those were. Now that's just I. And I really don't like it that we don't have enough room to answer this. They'll give you a lot more room. They actually have a box for A, a box for B, and a box for C. But we're done with the first part of C, so we still have to do the second part of C. So the second part of C says determine if the graph has any horizontal asymptotes or slant. Write equations for those asymptotes or state that there's no horizontal or slant asymptote. So hopefully, if we look at our function, we can see that we have a larger degree in the denominator, so we will have a horizontal asymptote at y equals 0. So r of x has a horizontal asymptote of y equals 0 because, okay, the limit as x goes to positive infinity, or we'll do negative infinity first, f of x equals 0, and the limit as x goes to positive infinity, of f of r of x. Got to go back and make sure we use the right functions for these. So let me erase that, get it right. R of x is equal to 0, and positive infinity r of x equals 0. So we have a horizontal. This is I. And state that there are no horizontal. So we would just say for the rest of this, no slant. So don't just say there's a horizontal. Say there's also no slant. Okay, you got to say everything. All right, so that is a video for free response question 1.